working is we are going to use mathematics. You use numbers to solve our problem. But this is what we mean when we say concept of induction. Trying that something that have been given already, a formula that has been given, it works and it will work for all of them. Okay, so let's now put this thing mathematically. So these are the 3 steps we are going to go through. Step 1, check P of 1. Show that it is true. Then step 2, check that when you substitute n is equal to k, we assume that that statement is true. Should imply that when we substitute n is equal to k plus 1, this induction problem should work. So these are the 3 steps we are going to go through this morning. Okay, so the same thing, I've repeated it in several cases for you to have an idea what we are supposed to do. Okay, so normally, you will have to form your proof or your steps in this. Show that the base step is true. That is n is equal to 1. Sometimes it will be, if not n is equal to 1, you'll be given as, and some questions will say n is equal to 0. Sorry. Sometimes be given when n is equal to 0. So if it doesn't work for n is equal to 1, you will check when n is equal to 0. And if it works for that base step, then we substitute when n is equal to k. If it also works, then we check n is equal to k plus 1. So these are the steps we will try to follow in a question. So let's take the first example. Let's take the first example. So this is how the questions are like. If you look at the past questions online, the first question that was given in induction was this one: 1 plus 2 plus 3 up to plus n. If it is equal to the formula on the right, half times n plus 1 for all n greater than or equal to 1. Now, you know that when you say n is greater than 1 or equal to 1, that means that you're talking about natural numbers. So we are saying that this addition of natural numbers, 1 added to the next number, added to the next number, all the way up to some n, can we use the formula half into brackets n plus 1? Is it true? Well, can we use that to prove that? Okay, so we want to see what a question like this entails. So I'm going to go through the steps one by one. So remember the base step, the hypothesis step, and then the inductive step. So let's start with the base step. Remember the base step, you are going to substitute n is equal to 1. So this n is equal to 1. We are going to substitute that into our formula. So if I substitute P of 1, on the left-hand side, we are adding these numbers. Okay, we are adding these numbers. So if I say n of 1, it means I'm adding this first term that I have here. So you see that on the left-hand side, I've written P of 1 will be equal to 1. Now, on the right-hand side, I have half into bracket n plus 1. So wherever I see n, I'm going to substitute the value n is equal to 1. So I'm going to substitute, when n is equal to 1 here, I'm going to get 1. And then the second part, I'm going to get 1 plus 1, which is equal to 2. So half times 1 times 2, I hope you know that that will be equal to 1. The 2 will cancel the 2. The answer is equal to 1. Now you can see that because the left-hand side is equal to the right-hand side, I want to write some few things here. So I'm saying that because we can say that the left-hand side is equal to the right-hand side, then we can say that this step, P of n, is P of n that was given. And we show that when P of 1, it shows that this implies that this P of 1 is true for the left and is true for the right. It means that P of 1 is true. So remember, what we are supposed to do. We are supposed to show that P of 1 is true. Remember the first step. So show that when n is equal to 1, this statement is true. And that is what we have done. It's true for the left, and it's also true for the right. Okay, so the next step is to do n of k. But I want us to appreciate what this induction problem is like. So in the next slide, even though it's not part of the proof, I want us to go through what is P of 2, what is P of 3, what is P of 4, what is P of 5, okay? This is not part of the question, but I'm trying to explain what this question does. So if, for example, you see an MCQ and it says that, what is P of 2? So on the left-hand side, P of 2 means that I'm going to add these first two values, okay? So on the left-hand side, I'm going to add 1 plus 2. And 1 plus 2 will give me the value to be equal to 3. Now, then when I come to the left-hand side, I'm going to substitute the value n is equal to 2. Remember, you're substituting n is equal to 2. So wherever n is, I'm going to put 2 there. So I'm going to have half times 2 times 2 plus 1, which is 3. And what should that give me? 1 over 2, then times 2 times 3. My answer should be equal to 3. So you see that the left-hand side is also equal to the right-hand side. What I had on the left is the same as what I had on the right. Let's try, let's say P of 3. So P of 3 means that we are adding the first 3 terms. So this time, I'm adding 1 plus 2 plus 3. So plus 2 plus 3. And that should give me 3 plus 3, that should give me 6. Okay? Now, so if I come here and I substitute n is equal to 3, this time n is equal to 3 into the formula, I'm going to get half times 3 times 3 plus 1, which is 4. So that means that this will be this times 3. This will be times 3. And this times 4. Okay? And what do we get? We end up getting 6, isn't it? So you see that whatever we substitute into the formula on the left, if they say find P of 4, it means we add 1, 2, 3 plus 4 on the left-hand side. On the right-hand side, we are going to substitute n is equal to 4. So it doesn't matter whether you do P of 1, P of 2, P of 3. We can continue on and on and on and on. You see that whatever we get for the left-hand side will be the same as when you substitute n is equal to that value on the right. So that is why we are saying that this induction problem, they prove that a particular formula is correct. Okay, so if you care to do more, you can do P of 4 and check P of 5. You see that whatever we get on the left will be the same as whatever we get on the right. Okay, so that is how this works. Angela, what's your question, please?
And sir, please, when you were verifying the answer with the right-hand side for the P of 3,
yes,
I realized you did 1 plus 3, but we didn't use the answer 6 we got. So that means that if, let's say we are doing P of 4, if we do 1 plus 2 plus 3 plus 4, when we are solving for the right-hand side, we just add the 1 plus the 4.
No, on the right-hand side, you substitute the value of n. You see, this is n. This value you have here, this is n is equal to 2. This is n is equal to 3.
Yeah.
And this is n is equal to 4. So
okay,
when you come to the right-hand side, you don't take the answer you got on the left. No, you take the value of n. So you see, that is why when we got here, we took n is equal to 3. This 3 we have here. That is what we place here. And then remember the formula is n and then n plus 1. So if n is equal to 3, it becomes 3 here, and this becomes 3 plus 1. That gives you 4. That's why I ended up getting 3 and 4.
Sure, yes. Thank you.
Welcome. Okay, so this is how the induction problems work. And I'm saying we don't need to do all these answers or try all these values before we go on. when you do the first step, which is P of 1, that is enough. And then we go to N of K, because the step says that do N of 1, and then come and do N of K. It means that take any value of N, but this time don't use a whole number, use the variable K. And then you come and do K plus 1. We are assuming that if K is 3, it will work. If K is 4, it will work. If K is 5, it will work. On and on and on. If K is 100, it should work. So if it works for any K, then we can say that any K plus 1 should work. So that is the step we call the hypothesis step. So this time, we are substituting N is equal to K. And please, the statement says that when you substitute N is equal to K, so 1 plus 2 plus 3 up to plus K, okay? So wherever I see N, remember the original problem. This is my original N. 1 plus 2 plus 3 up to N is equal to half N, N plus 1. So wherever I see N here, I'm going to replace it with K. So that is what I have done here. So 1 plus 2 up to plus K is equal to half K, K plus 1. And this step, because it's a hypothesis, it's an assumption. You don't prove anything. You don't prove left-hand side. You don't prove right-hand side. You only substitute. So my left-hand side is the addition of the numbers 1, 2, 3 up to K. That's my left-hand side. This is my left-hand side. My right-hand side, wherever I have N, I substituted it with K. And I say that this statement, I am assuming that it is true. You will write by the statement that I'm assuming that this statement, that is N is equal to K, this statement N is equal to K. I'm assuming that this N is equal to K is true. So if it is true, anywhere I see this value, I can come and use the result to work. It's a very important step. If you don't make this statement, we cannot go forward. We call this assumption step. Now, the last step is called the inductive step. This is the last step when we substitute N is equal to K plus 1. N is equal to K plus 1. So watch what I am about to do. Remember that the original problem is 1 plus 2 plus 3 up to N. But this time, it's 1 plus 2 plus 3 up to K plus 1, because I'm ending at K plus 1. Now, remember that when we substitute N is equal to K, this one, I ended at 1 plus 2 plus 3 up to K. That's where I ended, because that's the last step, okay? But now they are telling me that my last step should be K plus 1, so I've ended here. Now, please watch carefully. What do we do next? I'm going to ask you a very basic question, and in all induction problem, remember this basic problem or basic assumption. Now, if I am adding numbers 1, 2, 3, 4, 5 up to 10, for example, what number comes before 10?
9.
9. Thank you.
9.
So now, if I'm adding numbers like this, 1, 2, 3, 4, 5, up to what I'm calling K plus 1, what step comes before K plus 1? Who can tell me?
Say 9.
No, not a value. Now talk in terms of variable K. If K is 10, if K plus 1 is 10, what is K? You are telling me it's 9. So
Yes.
if I'm adding numbers up to K plus 1, what variable or what number should come before K plus 1?
K.
K, thank you. This is a very simple technique that we are going to use. So this addition, 1, 2, 3, 4, 5 up to K plus 1, I'm rewriting it as 1, 2, 3, 4, 5 up to K like this before I'm adding the K plus 1. It's like I'm saying 1, 2, 3, 4, 5 up to 10 is the same as 1, 2, 3, 4, 5 up to plus 9 plus 10. That's all I'm doing. I'm not doing anything differently. I'm only saying that adding to 10 is the same as adding to 9 and then adding the 9 plus 1, which is 10. So this statement I have here, you should be able to see that it's the same as this statement I have here. Now, please watch carefully. You ask yourself from here, this 1, 2, 3, 4, 5 up to plus K, this particular example, this one, okay? what is this statement if I put a bracket around this? If I put a bracket around this, what statement is this? Or do you know anything that represents 1, 2, 3, 4, 5 up to plus k? Now I'm trying to explain this thing here. I'm saying that this 1, 2, 3, 4, 5 up to k, which I have here, I place a bracket around this. Now, don't you realize that this statement is a statement we claim that it is assumed to be true, the P of k statement. Now, let's go back and look at it. What was my P of k? When n is equal to k, there's one. We added 1, 2, 3, 4, 5 up to k. And we said that the result is this result I have here, this particular result. We are saying that this statement is this, okay? So if I'm now adding 1, 2, 3, 4, 5 up to k plus 1, but I'm able to rewrite it in terms of 1, 2, 3, 4, 5 up to k before the k plus 1, then I can go and borrow the result for 1, 2, 3, 4, 5 up to k. And that is what I have here. That is what I just highlighted a few minutes ago. That is my P of k. I don't know whether you realize it. Please let this one sink in. This is the whole step about induction.
So you are substituting this one for the formula, which is half k into bracket k plus 1 for the entire one plus 2 plus 3 plus
up to k. Exactly. This is the whole technique you need to just remember. If you're able to remember this, the rest becomes LCM and factorization. So now it is 1, 2, 3, 4, 5 to k is now represented as half k, k plus 1. And then the last term which we are now adding is this. Now you ask yourself, there are two ways in which you can solve this. I normally like to use my method, which I call the factorization method. But a lot of students are not very familiar with this. So I'm going to do the old school. When I say old school, I'll try and solve it using LCM, even though it will be difficult doing this online. But let's try this. Look at this. The LCM of here, what is here is 1 over 1. I hope you see it. It's 1 over 1. Okay? So if I'm using LCM, that means that on the left-hand side, my denominator is 2. On the right-hand side, my denominator is 1. Okay? So if I'm using LCM, even though I don't know how to do that here, my LCM in the denominator will be 2. Okay, now, so let's assume that I have a line drawn. If the LCM is 2, 2 will go into 2 how many times? We'll go into 2 just 1. 1 times this whole thing here will be equal to, so just forget about this line. So since the LCM is already 2, 2 will go into 2, 1. 1 times the numerator will give me k. That's the left-hand side, k plus 1. Now, so now let's go to the right-hand side. Remember, there's a denominator here, okay? This whole thing, when I finish, I'm going to put this under a denominator. But for now, well, I can do it right now. So the denominator here is 2. The numerator here on the left-hand side is supposed to be what I have here. Okay, so this is what I have. Now, let's look at the right-hand side. The numerator of the right-hand side is 1. Now, 1 will go into 2 times. So 2 will multiply the k plus 1, and we'll end up getting 2 into brackets k plus 1. Okay, now, so now let's solve this. Trying to solve this again. So please, where we are now is just trying to factorize a fraction. So again, I'm going to take the denominator. If I expand the numerator, I'm going to get k squared. I hope you see it. I'm going to get k squared plus k
plus 2k.
Plus k. Okay, then plus 2k plus 2. I hope you see it.
Yes, sir.
And then the denominator is equal to 2. Okay, now what do we do next? When we factorize the k squared, or we simplify the k squared plus 2k plus 2, we have a calculator, so we don't have a problem. So the numerator will give us K squared. I'm going to get K squared. Then 2K plus K will give me what? Is it not 3K?
K.
Plus 3K. Okay, all plus 2. It has decided to come to the next line. Okay, all divided by 2. Okay, now if we factorize this, maybe I shouldn't expand it. Let it itself come to the next line. Okay, so now this one, if we factorize the numerator, what do we get? We'll go to the calculator. We choose mode, we choose equation. An equation is 5. We are solving quadratic equation, which is ax squared, that is 3. My coefficient of my square term is 1. If k is x, it gives me 1. My coefficient of my x term is 3. And then the last one is 2. Okay? So when I ask you to tell me what my x1 is equal to minus 1. Now, I hope you know that when you say x equal to minus 1, then we are saying that we are having a divided by b. So the numerator is 2. X equals to minus 1 means that the first factor is x plus 1 or k plus 1. You know when k plus 1 equated to 0, you get k is equal to minus 1. Okay, then what's the next one? What's the next value for x? I get minus 2. So that will give me k plus 2. Okay, so now I can rewrite this in the format that I really like, is half like this, half times the numerator k plus 1 all times k plus 2. Okay, so now I am done. I have finished. I've been able to find the value of k plus 1. This is the answer I got. Now, when you do this, because sometimes the question can be very involving, you must now verify this answer that I have. Is it correct? We want to find out, is this thing correct? So that is why I am going to go through the verification mode that I have here. Let me pull this slide up a bit so you can see. So what do I mean by verification? Now, remember that this was the original right-hand side, half n plus 1. So when we want to verify, we are going to substitute the last step, n is equal to k plus 1, into the right-hand side. So this n here, I'm going to substitute this n with k plus 1. Then I'm going to substitute n here also, this n I have here with k plus 1. So let's do it together. The first n will give me k plus 1. Now this second n here, I'm going to get into bracket k plus 1. All this before, remember, plus 1. Because it's n plus 1. There's supposed to be a bracket here. K plus 1 or plus 1. Now, if you simplify this, is it not the same as half into bracket k plus 1 all times k plus 2. K plus 1 will give you k plus 2, which is exactly what we got when we started. Okay, this is exactly what we got by what we had here when we did the LCM. Okay, so all you do when you verify is to substitute n is equal to k plus 1. And sometimes students will tell me, say if the whole problem is do n is equal to k and k plus 1, then why don't we just substitute it and then get away with it? If you do that, you haven't shown. Michael, what's your question? I'm seeing your hand up. You haven't shown that this is true. That is why we have to go through this step the way we have done here. Michael, your question, please.
Yes, please. Thank you. So please, when we use the calculator for the equation, we've got x1 is -2 and x2 is negative. Sorry, x1 is -1 and x2 is -2. But you wrote +1 +2. I don't understand that either.
Okay, so let's look at it. When you say x is equal to -1, then it means that when you bring the -1 to the left-hand side, it becomes x. Negative crosses the equal to sign, it becomes x plus 1. Do you remember? It became x plus 1 is equal to 0. So this was the answer we got from the calculator. But if you want to write it as a factor, then it becomes x plus 1. That is why I wrote k plus 1. And when you get, the other one was when x is equal to -2, if you want to equate this to 0, then it means that it becomes x plus 2 is equal to 0. So now you can write this now as a factor. It becomes x plus 2 is equal to 0. And this one becomes x plus 1 is equal to 0. So because we are writing that this solution, if you take your time and equate these two values to 0, you see that k plus 1 equals to 0 will give you k equals to -1. K plus 2 is equal to 0 will give you k is equal to -2. And those are the answers we got on your calculator. So we just rewrote them as factors. That is how I got the solutions I had. Any other question, please? Okay, so this is Angela. Your hand is up too.
Okay. Sir, please, I'm okay with what you did, but with the factorization aspect, I'm a bit lost. Where we use the calculator, before we were about to use the calculator, I actually want to know how come we got the K2 plus the 3K.
Okay, but you at least up to here.
Yes,
this
please.
is where
Just
up to here you were okay.
yes, but with
Okay,
the no, please. We'll start from
so from
there.
here.
Yes.
From here.
Yes.
Okay, so this was the original question, and I wrote them in the form of a fraction. So let me use colors to be able to know what we are doing. So this was a problem. Okay, and we were supposed to factorize, or we are supposed to solve this. And I said the left-hand side, the denominator is 2. The right-hand side, the denominator is 1. So it means that 2 and 1, the LCM will be 2. So I brought 2 here at the denominator here. That's the first part. Now, then we now ask ourselves, this 2, the denominator 2 will go into 2 how many times? It gives us 1. So 1 times k plus 1 will give me the numerator I have here, k plus 1, which is the first term. And then this denominator 1 will go into 2 how many times? It will go into 2 times. 1 times 2 will give you 2. So 2 will multiply the numerator. So it gives me 2 into brackets k plus 1. Now, take your time and expand it. What is k times k? K times k will give me the k squared I have here. This first term. That's the first value. Then this k times 1 will give me the k that I have here. This is the second term. So k squared plus k. Then I came to the right. 2 times k will give me 2k. And that is the third term I got, 2k. And then 2 times 2. This 2 here times this 2 there. That gives me the value that I got here, which is 2. Okay, so the numerator is k squared, k, 2k plus 2. Now, look at this, 2k and k. This is 2k is the same as 1k plus 2k. So I group like terms. Okay, so when you add k to 2k, that gave me this 3k that I got here. So this numerator now will simplify to k squared, 2k and k will give me 3k, and then plus 2. So that is how I got this equation that I have here. And that is what we chose to put into the calculator. Remember, k can be my x. So I substituted the coefficient of k squared as 1. Okay, like I did here, coefficient of x as 1. So 1, the coefficient of k as 3, and coefficient, the constant term is 2. And then the first value was -1, the second value was -2, which I have explained from Michael's question, that x minus 1 will give you x plus 1.
Okay,
Angela, I hope you're okay.
Yes, please.
Okay.
Thank you.
Welcome. Solomon, what's your question, please?
Sir, please, can you use your method so that we can differentiate the two?
I was waiting for that. Okay. So it means that I have to try and duplicate this, and so that we can look at my method. Now, my method will not use what you guys did. So I'm going to take away all this. As for the verification, it will be the same. So let me leave it like that. But this was where we got to. Let's start from here. So this was the problem. And here too, well, I can leave it like that. So this was the problem. Now, my method is called the factorization method. Factorization is, look at these two terms. The first term on the left is half k plus 1. The second term on the right is k plus 1. Then you ask yourself, what is common here? And it is common there.
K plus 1.
K plus 1, good. So I'm going to factor k plus 1 out. So I'm factorizing k plus 1. And there is something which I do when I'm factorizing this. Even though there is, remember that originally there was nothing here. I wrote this like this. I brought the 1 over 1 here. There was nothing there. So even though there is a fraction for the left term, the right term, there's no fraction. I am still going to factor out the fraction on the left term, assuming that it will affect what is on the right. So even though there's no fraction here, I'm still factorizing the half out. Okay, just watch me carefully what I'm about to do. So I've taken k plus 1, which is common here, and it's common there. And I've also taken half. There's no half here. So now, let's now factorize. I'm bringing a bigger bracket. Okay, so if I've taken half, and I've taken k plus 1, what will be left for the left term, this one? What will be left?
K.
K, good. So look at it, I'll be left with k. Now, remember that I have taken k plus 1 already, which is this term which I have taken. So this place is supposed to be left with 1. It should be plus 1. But remember, this fraction that I have here will multiply whatever I'm writing here as well. So I must introduce a constant that will cancel the denominator and make the answer to be equal to 1. So what constant can I introduce that can cancel the denominator 2? So that the result should be 1.
2.
2. Those of you who understood it, then that's the end. This was the answer we got at the end, this answer. And you see that my step is the easiest and it's the fastest. I'll go over it again.
But sir, please, you open. Sir, please, you open a bigger black bracket.
Yes, I can leave it like that. I just realized I'm just finishing that. That bigger bracket doesn't change anything.
Okay, sir.
So it means that this one half times k will give me half k plus 1. And then half times 2, half times k plus 1 times 2. The 2 will cancel this 2, and I'll be left with k plus 1, which will give me the original thing here. So I can simply leave, change this bracket to the normal brackets. That is why I finally did that, because it wouldn't make any difference. If I ended up getting, let's say, a quadratic equation, then I'll factorize the quadratic equation. But this example, that is all that I'm left with. So you have to choose whether my method is easier for you or you prefer your LCM method, which for me, I think is old school. But if that's what you're familiar with, I won't fault you for that. It depends on where you are.
Please, can you go
over your method again, please?
Yes.
Okay.
Yes, sir. Yes, sir.
Okay, I'll do that.
Sir, please.
Now. Yes, I'll go over. So, is that the same question you want to ask?
Yes, sir. But my question was, you see, at first you brought 1 over 1, like the fraction on your right. 1 over 1 into bracket k plus 1. Yes, that's right. Yes, sir. Is it going to change? Is it going to change?
No, it won't change anything. I mean, if we have left it like that, the same thing would have happened. Okay, so they are asking me to start all over again. So let's go over it, the first part again. Now, remember that we said that when you are given the problem, you want to find out what is common to the left and is common to the right. What is common is only this k plus 1, which we have here. K plus 1, which is we have here. So that is the only thing supposedly I'm supposed to factor out. So I'm supposed to have factored out just k plus 1. That is what is common to the left and to the right. But I'm saying the ingenuity about my method is that in factorization, most of the time when we factor, we don't want to get fraction in the next bracket. We don't want to get a fraction here. So we want to pull out any fraction, whether it's on the left or it's on the right. I'll pull it out. It's a technique which when you practice, you master it. I mean, more examples will help you. So even though there's no half here, I still factored out half. And I'm saying that it will only affect what I'm going to do in the next 10. Then I chose to use a bigger bracket to represent what I'm about to do. So this big bracket, I asked myself, if I've taken half, this has been factored out. This half have been factored out. And then this k plus 1, 2 has been factored out. So if I take that out, the only term I'll be left with is k. And that is what I got here. This gives me k. Then I come to the right-hand side. Now the right-hand side, because I have taken this k plus 1 out, remember, it's been factored out. I'm supposed to have been left with the value 1. Everybody can see that. I'm supposed to have been left with the value 1. But because there's a fraction here, if this fraction multiplies this 1, then I'm going to get half. But there's no half here. There's no 2 here. So I have to introduce a constant that will cancel this denominator. And then we'll make this thing go to 1. So you must ask yourself. So no, I tell students, whatever is the fraction, the denominator in the fraction, that will be the constant that you put here. It's only 2 that can cancel 2 and give me 1.
Yeah.
Okay, so if my fraction were to be 3, it means I'll introduce 3. If my fraction were to be 6, I introduce 6, because 6 will cancel the fraction. Okay, so for me to get this 1, I must change this 2 and change this value 1 to 2. So that if this 2 multiplies this half, I'm going to get 1. And 1 multiplying my k plus 1 will give me the k plus 1 I have here. So that is all this technique is about. You only have to take your time and factorize what is common, and then factorize a fraction, which will normally be for the first term. But the second term won't have a fraction. And you realize that the same thing will happen. I don't know whether this is clear. If not, you allow me to do one more example, and you see that I'll do the same thing again, which can help you to really appreciate what it's all about. So that is induction. And therefore, your conclusion will be, since we chose, when we use n is equal to k, we have been able to show that n is equal to k plus 1 is true. That means that the original statement of n is true for all. Okay, so this is how a problem like this, when it is given, you go through step 1, n of 1, step 2, n of k, this step 2, n of k, and then step 3, n is equal to k plus 1. Then the rest of the terms will be factorization or using LCM, depending on which one you are familiar with. Okay, maybe let's take one more example to see whether what I have done so far, you can do it. This time round, the same numbers, but this time we are squaring them. 1 squared, 2 squared, 3 squared, all the way up to n squared. It's giving us 1 over 6n, n plus 1, 2n plus 1. This time, our equation on the right is it has a denominator of 1 over 6. So let's go through the same step. What is n of 1? Please remember, when we say n of 1, it means we are evaluating the first term. The first term is 1 squared for the left-hand side. And you know that any number that is squared when you have a number that is squared, it will always be equal to 1. 1 where it's squared, it will always be equal to 1. So left-hand side, we are going to get this. 1 squared is equal to 1. Now the right-hand side is 1 over 6, n plus 1, 2n plus 1. And remember, we are substituting n is equal to 1. So here, this value n, the first value n here, I'm going to place the value 1 here. So that is 1. Now, the second value here will be 1 plus 1. And you know 1 plus 1 will give you 2. Now, when we put n is equal to 1 here, I'm going to get 2 times 1 plus 1. And 2 times 1 is 2, plus 1 is 3. Okay, so what is 1 over 6? What is 1 over 6? 1 divided by 6. Hey. What is 1 divided by 6? 1 over 6 times 1, then times 3. And the answer is equal to 1 over 6 times 2. Sorry, times 2, not times 3. Times 2 times 3. And the answer is also giving me 1. And because the answers for the left is the same as the answer on the right, it means that the P of 1, this value P of 1 is true. Say that this is true. Okay, so we prove the first step, base step. Now, then we go to step 2. N is equal to K. Now, remember that is the hypothesis or the assumption step. So wherever we see N, remember N is occurring in the left-hand side here, the last step, and N is occurring also on the right-hand side. So wherever I see N, I'm going to put K here. I'll get K squared. I'll get K here. I'll get K here. I'll get K here. So that's all you do for step 2. And that is what I've written here. 1 squared plus 2 squared plus 3 squared up to K squared is equal to half 1 over 6K, K plus 1, and 2K plus 1. Remember, this is an assumption, and we are saying that this statement is true for all n greater than or equal to K. This step, you don't do anything for left, you don't do anything for right. It's just substitution. Now, let's come to the last step, K plus 1. This is where the work is. Okay, so I've written a few up to this step. Now, remember the question I asked earlier. If you're adding 1 squared, 2 squared, 3 squared, up to K plus 1 term, this term, we are adding up to this term. What term comes before the K plus 1?
K.
What term comes? Is it not K? So you see that I've rewritten this thing from here up to here as 1 squared, 2 squared, 3 squared, up to K squared before the K plus 1 term. It's good to always write this so that when you finally factorize or you bring the formula, everybody understands. So this 1 squared, I don't know whether it was Michael who saw it earlier, 1 squared, 2 squared, 3 squared, up to K squared. I am going to borrow the previous formula. This formula, 1 over 6, K plus 1, 2K plus 1, to represent that addition. Okay, so from here up to here, I'm going to represent this addition as 1 over 6K, K plus 1, 2K plus 1. And that is what I have done here. This one, from here up to here. That is the formula I have represented here. Okay, I've done almost everything, but maybe from here, let me not do it. Let's do it together. Let me remove this. And also this one as well. Now, looking at what you have here and what you have here, maybe minimize all this so that we can be able to follow this 30 or so. Okay, now looking at this, what is common here and is common there? Let's look at it. What is common?
K plus
K
1.
plus 1.
K plus 1.
The thing common is K plus 1. Okay, so
Yes.
if I factor the K plus 1 out, okay, remember what I did using my method was also to factorize the 1 over 6, even though 1 over 6 doesn't show on the right hand side. Remember, just like I did for the other side, this is 1 over 1. There's no fraction there. Okay, so now if I factorize 1 over 6K plus 1, I'll be left with this K here, and I'll be left with this 2K plus 1. Okay, so let's put it there. So here, I'll be left with K. This time, my big brackets have to come. Okay, I think it will be good. I go to the next line from here. Let's come to the next line. So here, I've taken this K plus 1 out. So I'll be left with this K, and then into brackets 2K plus 1. Okay, that is for the left-hand side. I've taken care of from here out to here. Now let's come to the right-hand side. This is K plus 1 squared, and I've taken K plus 1. So what should be left?
So
1 squared.
1 squared.
There's no 1 squared.
Oh,
It's
K plus 1.
K plus 1. K plus 1. It's K
K
plus 1 squared, and I've taken just one of it out, isn't it? It is
Yes,
squared.
sir.
Okay, so it should be left with K plus 1, isn't it?
Yes,
K
sir.
plus 1 times K plus 1 will give you K plus 1 squared. So I should be left with K plus 1 like this. Now, but if I multiply this K plus 1 times what is outside the bracket, I'm going to get K plus 1 squared over 6. I hope you see it. I'll get K plus 1 squared over 6. But the original problem, there is no denominator 6 here. So I have to introduce a constant in front of this k plus 1 so that it will cancel the 6 so that I'll end up getting the k plus 1 squared that is showing here. So what constant should I introduce in front of this k plus 1?
6.
6, isn't it? Just like the other one, we introduced 2. So this 6 will cancel this 6. And then you end up getting what you have here. Now, we now have to, as for what is outside the brackets, it is okay. Now we have to factorize what is inside the bracket. So now let's go inside the bracket and do that. Okay, so inside the bracket, what is k times 2k? Is it not 2k squared?
K squared. Yes.
2k squared. Now then we have k times 1. Is it not plus k?
Okay.
Yes.
And on the right, 6 times k. Is it not 6k? And then 6 times 1. Is it not plus 6?
Yeah.
6.
Okay, so that's my bigger bracket. Now, so please, now I'm concentrating on this bracket here. When you add k to 6k, okay,
7K.
what do you get? I get 7k.
7K.
So this thing can be written as, again, I have to reduce this more, 28, I think. Now, so if this will give me 1/6, 1/6, then outside the bracket is k plus 1. Now, then the 1 inside this bracket, I'll get 2k squared plus 7k
Plus 6.
plus 7k plus 6.
Yeah.
Okay, now this is where you now go to the calculator and let the calculator do the rest of the work for you. Now, you must also be smart. If the calculator gives you something like 0.5, then you know it's 1/2. It gives you 6 over something. So let's go to the calculator and put our coefficients there so that we know what our final answer will be like. What will be in this bracket? That's all we want to do. Now, so let's take calculator mode. Equation 5, quadratic is 3. Now, the coefficient of the square term is 2. The coefficient of the kth term, x term, is 7. And then the coefficient of the last term is 6. Okay? Now, so what is x1? X1 is 3/2. Okay, now who can give me if x is equal to 3/2, if x is equal to 3/2, then what should be, when you equate it to 0, what would it be equal to? Is it not 2x plus 3? Yes, yes. 2x plus 3. Okay, so the first one will be 2x plus 3. Into bracket 2k plus 3. Now, you know, please, multiplication is commutative. So whatever the answers are, we can swap it and rewrite it. What is x2? Oh, x2 is just -2. So why didn't they give me that one first? So I could have written here x plus 2, sorry, k plus 2 before the 2k plus 3. Okay, so that is my equation. And if I remove the bigger bracket, it becomes k plus 1, k plus 2, and 2k plus 3. Now, the last part is the verification mode, and I think that is what I was trying to do. So verification mode, remember the original equation. Remember the original equation. This was the original equation. So I'm going to put k plus 1 into this right-hand side to know whether the answer we got here is the final thing. Okay, so I want to put the equation somewhere here so that I can see. Control V. Okay, so here, this n will become k plus 1. So that is what I have here. Okay, so the first n becomes k plus 1. Now, what becomes the second n? Remember, the formula says 2n plus 1. So if I place k plus 1 here, it becomes k plus 1 plus 1. What is k? K plus 1 plus 1. Is that equal to k plus 2?
Yes, sir.
Yes, this will give me k plus 2.
K plus 2.
Now, the last one, if I put n is equal to k plus 1 here, it becomes 2 into, that one I'll write it. So 2 into bracket k plus 1, or plus 1. Now, if you expand this, you get 2k plus 2 plus 1. Is it not 2k plus 2 plus 1? Is it not equal to 2k plus 3?
Plus 3.
Exactly. Yes. And that is exactly what we got when we did the factorization. Okay. Please, I'm being frank with you. Whatever will come in the exam, I have done it today. So if I were you, if you want to solve questions on induction, just take your time and go through this example yourself. If it is this one, fine. You go through this 3 steps. If it's the first one, you go through the step I went through. So basically, this is how the questions are given. They'll give you an equation like this. P of n is equal to this, and show that prove by induction. Or the first one that we did, yeah. Given P of n is equal to 1 plus 2 plus 3 up to n, half n plus 1, prove that it is true for all n. So this is what induction is all about. We spent almost an hour on this, but I hope it will help depending on whether you want to choose this question or not. But please, like I said, to treat induction completely, I need to do not just addition. There are examples called subtraction and division. Now, because I want to give an example of combinatorics, I only do one example on division, just one. Okay, so please, the exam question is on division. So even if this example doesn't go well with you, or you need to go by it several times, your question will be on summation. The first 2 examples that I've done. But there are questions in induction that says that find out whether something is divisible by something. So this is an example. If you have 7n minus 1, is it true that this function P of n is divisible by 6? Now, what is my base step? Remember, we are going through 3 steps. N is equal to 1. So when we substitute 1 here, we are going to get 7 raised to the power 1 minus 1. Now, 7 raised to the power 1 will give you 6. Okay, sorry, 7 raised to the power 1 is 7. Minus 1 will give you 6. So we are asking ourselves, this answer 6. Is 6 divisible by 6? Is 6. Can 6 be divided by 6? And if 6 is divisible by 6, if it is true, that means that P of 1 is true. Now, 6 divided by 6 will give you 1. So it means that P of 1 is true. Okay, so that's step 1. Now, step 2 says that when we substitute n is equal to k. So that is what I have here. Okay, so let's substitute n is equal to k. Let's substitute n is equal to k. Now, so wherever we see n, we put k there. So 7 is the power k minus 1. Now, we are asking ourselves, is this statement, let's assume that 7k minus 1 is divisible by 6. Remember, the second step is an assumption, so we don't prove anything. So when we write it, we leave it like that. 7 is the power k minus 1 is assumed to be divisible by 6. And we assume that that statement is true. And the last step is the k plus 1. Now, this thing, let me start from here. I've done it, but I want you to see how it is done. Now, look at this carefully. Now, if I substitute k plus 1, I'm going to get 7 raised to the power k plus 1 minus 1. Now, from the laws of indices, we know that when you have a number raised to the power something plus something, then it can be written as that number raised to the power k times that number raised to the power 1. I hope you remember this. This can be written as 7 raised to the power k, then times, what is times? Times is the dot sign, times 7 raised to the power, so 1. 7 raised to the power 1. Okay, so that is the k plus 1, or minus 1. Now, so if you remember what we did in the addition, anytime we are given k plus 1, we want to try and pull out the kth term, 1, 2, 3 up to k before k plus 1. So this term that I have here, I want to see this term that I've written here, this 7k minus 1, inside this. Can I write it inside this? Now, so watch me. I'm going to do it. Now, if I factor out of this term, if I factor 7 raised to the power 1 out. So if I factor 7 raised to the power 1 out, and I bring a bracket, the first on the left, this left-hand side, I'll be left with 7 raised to the power k. Sorry. I'll be left with 7 raised to the power k. And then what would I be left? This is where the problem is. This place is minus 1. I factored 7 raised to the power 1 out. Okay? So it should have been what I should have been left with 1 over 7. That is what I should have been left with. For this to be correct, I should have been left 1 over 7. But we don't want to have fractions. If you remember what I did in addition, we don't want to have fractions inside this. So I'm going to do a technique so that you learn in factorization. I'm still going to write minus 1. Remember, I need to see 7k minus 1, which is my P of k. Remember this. I need to see this. Now, so ask yourself, if I expand the left, what will I get? If I expand the left, I'll get 7k plus 1, which is this term. If I expand the right, I'll get minus 7. Please listen carefully. If I expand 7 raised to the power 1 times 7 raised to the power k, I'll get 7 raised to the power 1 plus k or k plus 1. It's the same thing. Now, if I multiply 7 raised to the power 1 times minus 1, I'm going to get minus 7. But I need minus 1. So what do I add to minus 7 so that it gives me minus 1? Can somebody help?
Minus 6.
No, if I add minus 6, it becomes minus 7 minus 6. So
6.
I should be plus 6. Thank you.
6.
Thank you. Now, please, now watch. This is where induction, or this is where the concept comes in. Remember that this is my P of k. Remember this. This is my P of k. And we said P of k is divisible by 6. Now, if you know 6 times table, please let me do some crude mathematics that I learned in my primary school at Nima. What did I do? I'm picking this. Now, you know 6 times table. 6, 1, 6. 6, 2, 12. I'm saying that if you pick 1, this value. If I pick this value, 6 times 1. Just allow me to do a few. 6 times 1 is equal to 6. What is 6 times 2?
12.
Do you remember 6 times 2? Okay.
12.
So 6 times 2 here is going to give me 12. Now, do you realize that this 12 is actually equal to the previous 6 that I got here plus 6? This 12 can be written as the previous 6, the 6 I got here, plus 6. That is why I'm getting the 12. Okay.
Yes.
So follow the argument. If I found out that 7k plus 1 is equal to 7k, this is 7k, this P of k. And this P of k, we assume that is divisible by 6. I'm not, okay, am I a co-host? I can mute, sorry. Okay, so I'm saying that this 7k plus 1 has been written at 7k minus 1, all multiplied by some constant, plus 6. But we already have established that this thing is a multiple of 6. 7k minus 1 can be divided by 6 from the previous example. So if this thing can be divided by 6, and I multiply it by a constant, any multiple of 6, if you multiply by a constant, that multiple will be divisible by 6. And then I'm adding a constant of 6. That is why I try to show you the 6 times table. If something gives me a result, I call this P of k. And then after getting P of k, I added plus 6 to 8. Even though I don't know what P of k is, since P of k is divisible by 6, and I'm adding plus 6 to it, that means that the whole thing here is divisible by 6. That is what the argument I'm using here. P of k is 7k minus 1. And I'm saying that if I add plus 6 to it, it means that this whole thing here is divisible by 6. So that's what I've written here. 7 raised to the power 1 times P of k plus 6 will be divisible by 6 because this originally is a divisible by 6. Hence, it's true for P of n. Okay, I don't know whether it went down well the way I want to, but please it is still using the same concept that we did in summation. And that summation, basically, you will find when you have k plus 1, try and see p of k inside. And since you use the result of p of k, you can now come and infer that if it works for k, it should work for k plus 1. But in division, we only show that if something is divisible by, let's say, n, then it should be p of k plus the n. So if you see a question, something is divisible by 6, you should see p of n, p of k plus 6. If you say something divisible by 3, you should see p of k plus 3. If you say something divisible by 5, you should see p of k plus 5. That is how you prove the problems like this. So something like this. If I say this is divisible by 3, then you see that by the time I'm finishing, I should get p of k plus 3. I'm not doing it. I'm just showing you. You see that when I do k plus 1, I'll get p of k, which I say is true, plus 3 times something. Then that statement is divisible by the term or the question you've been given. Okay, so please, this will sum up the induction. And I'm just repeating that if you choose to answer a question on induction, then the 2 questions I've solved should be a good example for you to practice so that you can be able to answer your exam question. Okay, we left with about 40 minutes, so it's enough, can take like 20 of it to show you how to answer the question on combinatorics. Now, please, for those who join us late, I'm doing all this because of the type of exam questions you are supposed to deal with or you are supposed to answer. And there will be 4 questions in session B, and you're supposed to choose to answer only 2 of them. You answer any 2 of those questions. So let me just show you, let's say the 2025 paper. This was 2025. So 2025 October, so June intake. So session B, you see that the first question is on inequality. Second question is on logarithm. Third question is on matrices. And then the last question is on induction. And so I'm saying today's lecture is because there will be a question on induction. Somebody may choose to answer that. That is why I'm doing what I'm doing today. So today we've answered this question. And then we want to answer a question that looks like this. So combinatorics will help us do that. So let's go back and take the principle and then an example on combinatorics. Okay, so combinatorics is basically, the concept behind combinatorics, like I said, is arrangement. Okay, so arranging things. So arranging or dearranging things, that's a concept. And in mathematics, we use it to simplify problems like gambling or like you have a very large number of items. You want to find a choice of a few of them. So the ability to do that in mathematics, we use methods like combination, methods like permutation, methods like addition and multiplication of problems. Now, the question you'll be given will be on combination. So even though I'm going to give you the summary, please, our example should be on combination. Now, there are 2 types of combinatorics or arrangement problem. Arrangement that allows you to use addition product or using addition. Now, if you are given an event, and then the event, for example, let's take the ladies. I think I've answered a question like this in class before. If ladies have, let's say, 4 blouses and then 5 skirts, 4 and 5. 4 blouses, 5 skirts, and then let's say 10 full dresses. And the question says that how many possible attires does this lady have? How many attire? How many dresses, complete dresses does this lady have? Now, you realize that for a lady to have a complete attire, it must be a skirt and a blouse. Skirt and a blouse. Now, I want to teach you the rule of using and or. The first rule is or. Or says that you use addition. And says that you should use multiplication. So if the lady has skirts and blouses as attire and then her full dresses, then it means that that lady has skirt and a blouse, or a full dress. Now, so you look at the numbers for the skirt, you look at the numbers for the blouse, and then you multiply. So I remember I said 4 and 5. So 4 skirts, 5 blouses. So it becomes 4 times 5. Skirt and a blouse, 4 times 5. Or a full dress. Then or you use addition. Okay, so when you are given a problem, you must ask yourself, the events, are they mutually exclusive? It means that can they both occur without having a problem? Okay, so skirt and a blouse or a dress. You realize that it becomes and then or. And then you use the principle of and being multiplication and all being addition. So that is a rule for addition, and that is a rule for multiplication. When you see and, multiply. When you see or, you add. Now, then when do we use permutation? I don't ask questions on permutation, but basically permutation says that when you are arranging and the things you are arranging are not in order, okay? An order arrangement, okay? Sorry, they are in order, but they are not distinct. So then you use and permutation, whatever. Now your calculator, permutation is normally on the, where is it? On the multiplication sign. So look on the left on the calculator, you see that you see NPR is on the multiplication sign. So that is, if you know what N is, let's say 10 permutation 2. So you key in 10, you key in shift, and then the permutation sign is times. The P comes, then you key in 2, and it will give you the answer. Okay, so if you know that the problem is permutation, you come and use the symbol multiplication. But combination, this is an example of permutation, for example. It says that you want to form dance partners. Selected groups are 12 women and 20 men. So it means that we have 20 permutation 12. 20 permutation 12. So here it becomes 20 shift and then the permutation sign, then the 12. And you see that the answer is some big number. Some big number. Basically, that is what you do. Now, but if the question is not permutation, then it will be a combination. I'm saying your question will be a combination. Combination is when your items are not ordered. So please look at it. For here, the items are not ordered. So how do you combine any problem that is dealing with combination? So you come to what your N is, and you come to what your K is, and then you choose your problem. Now, let's use, for example, the exam question that we saw earlier. Now, a club consists of 20 members, of which 9 males and 11 females. 7 members will be selected to form an event. How many committees can be formed, choosing 4 females and 3 males? Remember, they are choosing 7. So 20 people and they are choosing 7. But they want to find how many females can be chosen, how many males can be chosen. So how do you go about this? Remember, combination is when you have unordered. What is unordered? When we say something is not ordered, when you pick a male followed by a female, it's the same as picking a female followed by a male. That is why we say in combination, we do not allow order, because a male-female is the same as a female-male. It doesn't change anything. So you must identify what your N is. So you identify what your N is and you identify what your K is. So now let's see choosing the females. Now the females, we are choosing 4 of them. And what is the total number of females? That is 11. So you choose 4 from 11. And then the males, there are 9 of them. And then you are choosing 3 males from 9. So in this question, remember, you are going to choose a male and a female. I hope you know that to form a committee, you don't choose male or female. When you say or, either this or that. But for a committee to be formed, you choose male and a female. So we pick our calculator. Wait a minute. Okay, so I hope you see the calculator on the screen. Please, do you see the calculator?
Yes, sir.
Okay, so we are choosing males. There are 9 of them, and we are choosing 3. So it becomes 9 combination 3. And then n a female. So n, you know n is multiplication. So you come to the female. The females are 11. 11 females. That gives you 11 combination 4. Okay, and so that is your answer. So the question 14, if you want to choose a sub-question on induction, then you must prepare to solve a combination problem like I've shown you. If you are choosing committee, you use combination. Choosing players, you use combination. Choosing people, we use combination. Permutation is when you are arranging people in first, second, third positions. That is when you use permutation. Okay, so basically today, this is what I have for you. I don't know whether you have any questions for me. The rest of the slides basically is dealing with more examples on this. Michael, your question, please.
So please, so in solving combinatorics questions, do you have to show working, or you can just use the calculator and write the answers?
So you in your show working, because I'm online, you just tell us that you have 20 people made up of 9 males. So you say 20 people, 20 members, males are 9, females are 11. And then you are choosing 4 males, 4 females, and 3 males. Then you do what I did on the calculator. To choose a male, you choose 3 from 9. To choose a female, you choose 4 from 11. Then you multiply. So that's your working. The working must just write this in the answer booklet: 9 combination 3 and times 11 combination 4. You write the answer. That will be your working.
Simply, so do we write something like the 9C3 times on the paper?
Yes, exactly. Just
Okay.
like I showed you in the slide. You must write 9C3 times 11C4. That's 9 combination 3 and 11 combination 4. To show that you are choosing 3 from 9 and 4 from 11. That will give you the 20 people, and you are choosing 7. Any other questions? Yes.
Sir, so please, you write something to show that you are choosing 4 females from the 9, and then 3 males from the what do you call it?
So you are
11.
choosing 4 from 11 and then 3 from 9. Yes, that's what I'm saying. That first of all, you say that this is a committee of 7. You are choosing a 7-member committee from 20 membership, but the number of males are 11 and 9. The number of females are 11. So choosing 4 females, it becomes 11 combination 4. Choosing 3 females, it becomes 9 combination 3. And then because you are choosing a male and a female, you multiply the results. 9 combination 3 and 11 combination 4.
Okay. All right.
And then you put down the answer as the calculator gives you.
Hello, sir.
Okay, thank you, sir.
Yes, please.
Just please, sir. Sorry. Earlier lectures, we made some demand to him.
Okay.
Before God and man, some of us, we left school about 21 years ago, and following mathematics of this nature, at times it becomes a bit difficult. So I'm pleading if the audio visual will come early, so we go over it to be abreast of it. That's my humble plea, sir.
Okay. These days, because the institute have been clicking on record before I come in, I'm not able to record on my system. So even though I click on record, it's not recording on my system. If I were, I would have made the videos immediately after the class. So I think you must make this demand to the institute. They will have a recording. I don't know whether there's Thompson here who's a co-host. I don't know whether you were able to record. But for the past sessions I have, on the past 3 or 4 weeks that we've had, if I try to record, I don't have it. So it doesn't record on my system. So please try and ask the institute to make it available. Angela, want to say something?
Yes, sir. So I realized that on the LMS, the videos there are not ours. They are like 2024 like online lectures that you had with them on most of the topics that we've treated?
Yes. Yes. So actually, what happened last year, I was able to record almost all my lectures for distance learning. And those lectures, when I record them, I send it to the reps. So they are not on the LMS. I can check my system and see which ones I did with the distance learning student and make them available. Okay, so that I can do. I can look for those ones that I was able to record. So lectures, for example, lectures which I do like today, I make them available. Last week when I met the engineering students, I used my own Zoom link, so I was able to record and I made it as a video for them.
Please.
I made it available to the class rep. So Angela, I'll check the videos I sent to the previous class rep and see which ones are my lectures and I can make them available. But please, the institute is recording. I can see that they are recording.
Hello, sir.
Yes,
the
please.
institute they've been releasing some of the videos on the YouTube link and then they've shared it with us. So we'll post it again in our group.
Okay.
Because last week I wasn't able to join the series and sequence class, but when I went to the LMS, the video on series and sequence there was for 2024 class, but then I just went with that and I understood.
Okay. So if it is exactly your class, then please contact the institute. I think they have a site where they populate all this. So they don't put it respectively on our ERP on our model, not on our lectures model. So they will have it available for you. Maybe later on I should ask for mine so that I can also add it to your page as well.
Yes.
We'll talk more about that.
Perhaps more. We want to see the questions.
Okay. Richard, your hand is up.
Yes, sir. I was just wanted to confirm if it's going to be online, the exams, or...
That's online. That would have been interesting. Okay. No, it won't be on. It won't be online. What they'll do is that they use centers. There's a Takrady center. There is a Kumasi center. I know there's an Accra center. So you must, maybe next week when you come face to face, you can clear this up. But the last exam they did, there were people in Accra. I got scripts from Kumasi. I got scripts from Takrady. I think there was also one at O2, if I'm not mistaken, but please confirm. So you may have to tell the institute which of the campuses will be convenient for you, and then they will send the questions there for you to write on the timetable. That is what happened. That's what happened last year, but please verify from the institute.
Okay, sir, because I have a big issue about that.
Okay.
I am also
you mean
the country. How do I write the exams?
Okay. Well, okay. So please, this goes beyond me. I'm sure that the director and the institute will work something out because they know you are supposed to be distant students. And
yes, sir. Because I'm not in the country as well.
Okay. So let's talk. I'll forward your comments to the director myself. I'll find out what answers they have for you. If I'll share with the class rep. So please let's do that because last year there were some students. I must be frank, there were some students who were, what do we call it? They are impaired. They are impaired in a way. So their questions were converted electronically, and it plays like an audio for the person, and the person answers. But that was for special cases.
Okay.
Yeah, there was a student like that who wasn't writing a sit-down exam. He was doing the exam electronically. But I don't know the arrangement for those of you who are not presently around. So let's see what happens next week. If you can't even physically, so that means you won't even be around for physical meeting.
No, sir. That's the problem we are having now.
Okay, I'll talk to my immediate.
I'm learning when I finish.
I'll talk to the immediate coordinator, and I'll get some answers for you. Hopefully, by the end of the day, I'll send it to the rep so that it shares with you, so you can at least be rest assured of what can be done. If they can't physically do that, I'm sure they will arrange an exam for you. I don't know how, but definitely, definitely they should be able to. I don't know. Is your exam timetable out? I don't think it's out yet. So
no, sir, it's not.
okay. So let's at least do my midterm for me. It will be activated. I think tomorrow. So
okay, sir.
do the midterm and get that results done, and then we sort the exams out as well.
All right,
Okay,
sir.
Thank you, sir.
Have you heard anything about stress?
Sir, please, Pascal triangle.
Yes, Pascal triangle is coming. I thought we did one in class the last time we meet face to face. If those of you won't be available next week, then I have to do maybe a self-recording on this one. Okay, it's a very simple technique. It's not difficult at all. So I'll do a video on this and put it on the LMS for those who will not be available next week, because I want to solve these questions again physically in class with the papers I gave you the first time we met. So you can know how to handle that.
Yes, sir. No food stress.
Okay.
Sir, please, can we get this question on the LMS?
I think it's there.
Okay,
I think it's there. Let me verify.
Yes, sir, it's there.
It's there. The questions are there.
Yes, it's there. Past questions.
Yeah, they are here. So they are here. So that's the paper. This is the question, sir. May 17, 2025. Is
okay, sir. Thank you, sir.
Okay. So thanks for coming. I hope you realize that the math is math, but it is not as difficult as it is. I mean, if we can practice what we have been teaching you. So don't be too fixated, or what is the word? Exam phobia. That is the thing. Don't be too much afraid of what to expect. Well, so far as I'm concerned, whatever I have told you is exactly what you see. So just prepare adequately and realize that you'll be able to solve your question. Okay, so enjoy the rest of your weekend, the rest of your lectures. Okay, we'll see you go next week. And those we can't see you, we'll see what we can do also for you. Okay. Have a blessed weekend.
Thank you, sir.
Same to you.
You are the best, sir.
Bye. Thank you.
We love you, sir.
You
Thank
guys
you,
are
sir.
The question, no go ask.
Mahama, what the yeka? What ya den cry? What the yeka?
Cosref, good morning.
Yeah.
In fact, this is the time I have to start doing the contributions. Or else.
Recorded. You have been recorded. You have been recorded.
Oh, bro.
Be mindful of what you say here.
Oh,
I had never contribution, Sam. Why no?
It will be used against you.
You stop the recording now.
Everybody should come out for this line too.
It will be used against you. Mahama, what the yeka? Hey, today I don't see Sam. I don't see Sam Sherry. As you get message, no, Pabam.
You go ready.
Sam get a message, you know. You say Pabam.
Make I adjust the word for my papa. Mo, Obia Bajin share. If I crack my gun, Obia Bajin share.
Oh, last question over to LMS. Last question. Three different class questions. My questions they are almost the same. Figure even as a time. So, or say I have 4 questions. Answer to. We must start with. We must start with.
Please mute your mics, mute your mics.
Hello.
Hello, yes.
Charlie, I beg, what be the next class? I mean, my phone spoiled, so I know get the timetable some.
Hold on. The next class is moral phonetics.
Okay, where you be when the time?
11:15.
Sharp.
Yeah.
All right, thanks.
Please mute your mics. Mute your mics.
Okay, sir.
No, no, one. Say, who? Holy, I'm a new baby. So, not to count. That guy only. Oh, I remove some quiet guy. Oh, no, so Somalia.
Please, some of you, your mics are so on. Before you go and say something,
please, we can hear you. Your mics.
Ruben,
diploma from the class.
Hello, Ruben. Your mic is on.
Ruben, you are disclosing information, oh, please.
What's not that for? No one to. What's that of the toilet?
Hello, Ruben. Your mic is still on.
Sorry, I think I have quite Fine. Ini kamu mau juga bikin main. Ya, lu tahu udah. I'm telling you, one that you want to jump or one got the area from. I think it's done. So, fine. So, how you did not. No, I'm fine. If you don't tell me. You guys are thinking about that monthly 20. But I don't say any. Pretty time in that I concluded. Like I said, basically, Okay. That's a great name. That is, I want to read the document. These are very nice. But my questions are not my questions are not. How will you bound? Will you bound? That's the one. That's the good one. That cannot. Oh, yeah, red. Nice. Yeah. You do everything. We don't know. Is it occasional? We don't do occasional. Okay. Cannot be spoiled. One line. Ah, Let me see.